Hi and welcome to a tutorial again looking at how to graph quadratics, this time using the form of the equation y equals a outside of x minus h all squared plus k. You see it right down in the bottom middle of your screen there. This basic equation that we've got here is y equals x squared equation. You can see it is a parabola in the happy form passing through the origin. Now what I'd like to do is just vary these values of 1, and as you see as we move that up, increasing it, you'll notice that the shape of your graph, that parabola, becomes narrower. We call it dilated in the y-axis, and so this one in particular is dilated by a factor of 4 in the y-axis. If we bring it back down a bit, this one is now dilated by a factor of 2 in the y-axis, and the equation down here at the bottom left-hand side basically represents what we're seeing on the screen. You notice as we go back to 1 and then to 0, what happens to the graph? And as we go negative, we go from a happy to a sad graph. It looks like a bit of a frowny face. And the smaller the negative number, the steeper that line. Okay, taking that back to where it was, we can now look at the effect of the h. Now the h in here is seen in the, if we look at the equation down the bottom in the middle, that h is actually what's in the brackets. As we increase that, you'll notice as we move h to 1, our graph is translated to the right 1, and now to the right 2, to the right 3. And we can go back the other way. Now with the equation x plus 1 all squared, our graph is moved to the left 1. And again, you can look at the equation, you can see how that equation actually represents the graph itself. And moving back. So now what we've got is we've moved that vertice from the origin and it's moved across 2 to the left. So in other words, if we go x plus 2, we're translating our graph 2 units to the left. If we go to the right there and make it x minus 2, we've actually dragged our graph 2 units to the right. Okay, let's just set that up again. Back to our standard y equals x squared shape. And we'll investigate now the value of k and see what's happening there. And again, as you increase the value of 1, you'll see that the vertex or the vertice has moved up 1, 2, 3, etc. Now, while it looks like the shape of the graph itself is changing, it isn't, it's just being shifted upwards. And you can see that vertical shift is represented by this number by itself as 3. Okay, shifting that back down through the origin, we've now got x squared minus 1. So in other words, we've taken an x squared graph and we've dropped it 1. Okay, here we've dropped it 2. So if I keep that as it is, and then look at the value of h, you can see we can also do change multiple parameters. So here we're looking at the value of h and k changing, and we've got our vertice or turning point as now 1 across and 2 down. So our turning point is given in the equation as how far across we've gone and how far down we've gone, or up as the case may be. So let's change that again. So here, let's make that negative 3. Here by saying x plus 3 all squared, we're actually shifting it or translating it to the left 3 units. And by adding plus 2, we've not only shifted it to the left 3 units, but we've translated it up 2 units. So the transformations taking place in this particular graph is that our x squared graph, our basic x squared graph, has been translated 3 units to the left and 2 units up. We could actually put a modification in there, so I can now vary the value of a, and now my transformations in here, we have dilated our x squared graph by a factor of 2 in the y-axis. We have translated it 3 units to the left and translated it 2 units upwards. Okay. Thanks very much.